Hello everyone. In this video, we are going to see the construction of DC machine. A DC machine is a machine, electrical machine, which can act as generator or motor. When it is acting as generator, we need to give supply to the field winding alone. The generated EMF will be induced. The EMF will be induced in the armature winding, from which we can take the output. If the machine is going to be run as motor, then we need to give the supply, DC voltage supply, to both armature winding and the field winding. So this diagram shows the construction of DC machine. From the diagram, we can find that the different parts of the DC machine, which has the center part is the armature system, armature circuit or armature system. These are the field system. The armature system will have armature windings, armature conductors, which are placed within the slots of the armature. And then we will be having the commutators, which are placed at the end of the armature, whose purpose is to convert the EMF, AC EMF, which is induced in the armature, to DC voltage in the output circuit. And we will be having the brushes placed on the commutator, whose purpose is to collect the current from the armature conductor, and it will be passed on to the external circuit through the terminal box. And then we will have the yoke, and to the yoke, the field poles are placed, fixed. This is the structure of the pole, which will also have a broadened structure at this end, which are called pole shoe. This is pole shoe. And then the pole will have field winding on it, which will be given a DC supply through the terminal box. And then this is the outer cover, which is called as yoke. Then we will see the different parts of the DC machine and its role. The first part of the DC machine, which is the outer part of the DC machine, is the yoke, which is also called as the frame of the machine. The main purpose of this is to provide the protection of the entire system. So it will protect the entire machine, which will be which will protect the machine from dust, mechanical damage, etc. And in addition to that, it will also provide a low reluctance path for the flux. Then, if you consider the material used for the yoke, these are all basically low reluctance materials, which can be of cast iron, silicon steel, rolled steel, cast steel. And then it also provides the mechanical support for the poles. And for smaller machine, DC machines, the yoke will be of cast iron material. And for larger machine, it can be of cast steel or rolled steel material. Then coming to the poles, pole shoe and pole core. This is the pole shoe, and this is the poles, and you will have the pole core. The pole on the poles will be having the field winding. This is the pole shoe, which is the extended part of the pole, which will be of a shovel-like structure. The purpose of this is to provide the support for the field windings. It will not allow the field windings to come out of the pole, and it also serves the other purpose of spreading the flux into the armature core. Then this poles or pole shoe will be constructed from low reluctance magnetic material. Then we will have the field winding, which are placed on the poles. These field windings are wound around the pole cores. These are also called as field coils. The field winding of field coils can be of a series field winding or shunt field winding. That will be tilted. Based on those, we can classify the machine. The field windings are also called as excitation winding, because when we pass the current through the field winding, that will produce the magnetic flux or magnetic excitation. So it is also called as excitation winding. The material used for the field coils or field winding is enameled copper. Then we have the armature, which the armature has armature core and also armature winding. This is the armature core, and the armature core will have the slots on its surface. Into that slots, armature windings will be placed. The armature slots and the armature core, the slots will be housing the armature windings. The armature core will be of laminated. Why? Because to reduce the eddy current losses and the hysteresis losses. Then you'll have the armature windings, which are placed within the slots of the armature. The armature windings can be of two types, lap winding or wave winding. In case the armature windings are lap winding, then the number of parallel paths will be equal to P. Number of parallel paths is denoted by A, and P is the number of poles. And this construction will be used for high current, low voltage applications. And the second type of winding is the wave winding, in which the number of parallel paths will be always equal to 2, and it is used for low current applications. So this is the armature, the cross section of the armature core. Then we have the commutator and brushes. This is the commutator. Here in this figure, we have only two commutators. These commutators will be connected to the armature winding. This is actually the main part of the machine, which is like a cylindrical structure, which are hard drawn copper segments. So these are all constructed with the help of the copper segments. These segments, here we have two segments. These segments will be insulated from each other by thin layers of mica. The role of the commutator segments are, it reverses the current direction, and it maintains, in case of generator, it will be acting as a mechanical rectifier that converts the AC EMF induced AC voltage induced within the armature to unidirectional DC voltage as the output. And in case if the machine is going to be acting as a motor, then in case it will maintain the unidirectional torque. Then we will also have the brushes which are placed on the commutator. The purpose of the brush is to collect the current from the rotating commutator, and it will be distributing the current to the external circuit in case if it is a generator, or it will be supplying the current to the commutator from the external voltage which is given as the input to the armature. Then we'll also have the bearings. The bearings are used in order to have the smooth rotation of the rotation and to reduce the friction. And we'll be also having this shaft which will be connected to the armature core. This is the shaft, and the shaft will be connected to the external load if it is going to be a motor, or it will be connected to the prime mover if it is going to be a generator. Thank you.